We're going to look at steps to solve a rational equation. Step 1, you're going to identify the LCD, the least common denominator. Number 2, when you identify the LCD, you're going to multiply both sides of the equation by the LCD, and when you do so, I kind of like to think of it as fraction busting. If you do this properly, you'll be left with an equation that does not have fractions anymore. Step 3 is then solve the resulting equation, and finally you want to always check your solutions to make sure that the answers that you get don't make the original equation have a 0 in the denominator. This example says solve the equation and check the solution. So again, we have a proportion. When you have a proportion, you can cross multiply. So you're going to multiply across the equal sign. So we'll get 2x times the quantity x minus 4. We'll distribute that in just a second. When you cross these, multiply across, you'll get x squared times the quantity 4 minus x. Now we can distribute. So we have 2x squared minus 8x. On the right side, we get 4x squared minus x cubed. At this point, we want to set this equation equal to 0. So let's move the highest exponent, x cubed, to the left side of the equation so that it's positive. We'll move this 4x squared to the other side by subtracting it over. So you get negative 2x squared. When you subtract this over and combine it with positive 2x squared, you get negative 2x squared. And then finally you have negative 8x, and there's just 0 left on the right side. And at this point, to solve it, we're going to factor the left side, so we'll factor out an x, the greatest common factor. And this inside trinomial will factor further. So we'll go x and x, 4 times 2, and it's a negative 4 and a positive 2. And last, we'll apply the zero product property, and we'll get x equals 0, 4, and negative 2. Finally, you want to check your solutions, so that's the last step. If you get 0 and we plug it back in, for x, we get 4 minus 0, which is just 4, so that's fine. When you take 0 and plug it in on the right side, you have 0 minus 4, which is negative 4, still okay. So 0 works. When we plug in 4, though, you're going to get 4 minus 4, which makes 0, and you can't have that, so this can't be one of the solutions. And then finally, when you plug in negative 2 for x here and here, we're fine because it's not making the whole denominator equal to 0. So our final answers are going to be 0 and negative 2. This example says 6 over x minus 7x over 5 equals x over 10. So step 1, we're going to identify the LCD. So if you look at the denominators, let's start with the numbers first. You have 5 and 10, so you're figuring out which number will both of them fit into, so we'll use 10. And then the only other thing in the denominator we have would be x. That's our variable, so we'll also include x. So we have 10x as our LCD. Once we identify the LCD, we're going to times it to both sides of the equation. So we'll go 10x times the left side of the equation. And we'll multiply the right side of the equation also by 10x. When you do so, you're going to distribute. And this is where the fraction busting comes in. So when we distribute 10x to both terms, I want you to think of it as 10x times a 6 over x and 10x times the 7x over 5. The x's will cancel here, so x cancels with x, and you're just left with 10 times 6, or 60. Over here, the only thing that reduces the 5 divided by 5 is 1. 10 divided by 5 is 2. So you have to multiply what's left. So if you look at it, it's negative 2x times 7x, or negative 14x squared. On the right side, again, you're looking to see what will cancel to get rid of fractions always. So this whole 10 cancels with that 10, and you multiply what's left. So we have x times x, or x squared. Once you get to this point, you solve it like a regular equation. So what we'll do is we'll move the x squareds to the same side. We'll add 14x squared to the right side. So you get 60 equals, and that makes 15x squared total. Divide both sides by 15. So you get 4 equals x squared. And again, you're solving for x, so we'll square root both sides. Remember, if you write the square root into the problem, you need to add a plus or minus. So we get x equals plus or minus 2. Just double check, always check your answers. 2 and negative 2, if we were to take them and plug them back into the original equation, 2 or negative 2 is great because neither of them will make the denominator 0. So that's going to be, both of them will be our answers, 2 and negative 2. This example says 2 times the quantity x minus 7 all over x plus 4 minus 2 equals 2x plus 20 divided by 2x plus 8. So again, the first thing you want to do is you want to find the LCD, the least common denominator. This is already, we're going to consider it or look at it like a binomial. You have x plus 4. And over here we need to factor, and you can see you can factor out 2. Now we're looking at all the denominators. You have the quantity x plus 4. You also have x plus 4, but then this denominator also has a 2. So our LCD is going to be the 2 times the x plus 4. Once you identify the LCD, you're going to multiply it to both sides of the equation. Once you do so, you are distributing, and you're always looking to see what will make the denominator cancel. So when we take this 2x plus 4 and times it to this first fraction, the x plus 4's will cancel. Again, those x plus 4's will cancel, and you're going to multiply what's left. So you can see you have a 2 here, you have another 2, so we'll multiply what's left, so that makes 4, and I'll leave this for a second as x plus 7 in parentheses. The biggest thing you want to remember is not to forget to take this 2 times x plus 4 and distribute it to this negative 2. So again, because there's a 2, we're timesing, I'm going to think of this as 2 times negative 2 or negative 4, but there's still a quantity x plus 4 with it. On the right side, you just have one fraction, so there's no need to distribute. It's just one fraction. So now here, this whole 2 times the quantity x plus 4 cancels with the 2 times the quantity x plus 4. So the only thing you have left is 2x plus 20. On the left side, we'll combine like terms. The 4x and the negative 4x, they cancel. Then we have just 28, take away 16, which would be positive 12. On the right side, you still have 2x plus 20. We'll subtract 20 from both sides. So you have negative 8 equals 2x, or x equals negative 4. Don't forget, once you get an answer, you want to double check it with the original problem to make sure it doesn't make a 0 in the denominator. And in this case, if we take negative 4 and plug it in right here, negative 4 plus 4 gives you 0, which can't happen in the denominator. So this is not going to be an answer, and it's just going to be no solution. This example says 2 divided by x minus 10, and then we're subtracting 3 over x minus 2. On the right side, you have 6 over x squared minus 12x plus 20. So again, to find the LCD, these denominators are already in kind of, if you want to think of it again as binomial form, x minus 10, x minus 2, but over here we want to factor. So if you factor this, problems are usually rigged. Right here you have 2 times 10 is 20, and if you make them both negative, it definitely combines to give you the negative 12. And oh my goodness, look at that. We have x minus 10, x minus 2, and then over here we also have x minus 2, x minus 10. So that worked out really nice. Our LCD is going to be both binomials, x minus 2 and x minus 10. Once you identify your LCD, you're going to multiply it to both sides of the equation. Don't forget, here this is just one fraction, so when we're timesing this side by that quantity x minus 2, x minus 10, the whole denominator cancels with the whole LCD, leaving just 6. But on this side, we have to be really careful because there's 2 fractions. Again, it happens to be a minus this time. So when you distribute this to both fractions, on this fraction, you can see that x minus 10 will cancel with that x minus 10. Leaving just 2 times the quantity x minus 2. But when we take this expression and distribute it to this fraction, this time the x minus 2's cancel. So x minus 2 cancels with this x minus 2, and it's leaving a negative 3 times the quantity, the one that's left, x minus 10. So now when you can finish the problem, there's no fractions, it's really nice. Combine like terms. I'm going to subtract the 26 over, making negative 20, and then dividing both sides by negative 1. You get x equals 20. So again, double check that 20 doesn't make any denominators equal to 0, and we're good to go. So that's going to be our final answer. This last example is 10 over x squared minus 2x plus 4 over x equals 5 over x minus 2. So again, first step, we want to identify that LCD, and to do so, we want to look at this fraction on the left. Let's factor out an x. And so now you can see, if you just consider variables, you have x and then another x. And then we have x minus the quantity x minus 2 and the quantity x minus 2. So there's our LCD. We're going to times both sides of the equation by that LCD. So same thing, on the right side you're looking to see what will cancel out the denominator. The x minus 2 cancels with the x minus 2. It's just one fraction, so all that is left is 5 times x. And we distribute the x times x minus 2 to both expressions. On this first one, the x, they both cancel and the x minus 2's cancel. So this whole thing gets canceled out with this whole thing, and you're just left with 10. On the second fraction, 4 over x, when you take x times x minus 2 and times it over here, just the x's cancel. So you're just left with a positive 4 and then x minus 2. We have an equation with no fractions that we can finish solving. So combine like terms, you get 2 plus 4x equals 5x, and then finally move this 4x to the right side by subtracting it over. So you get x equals 2. And again, double check with that value. If we were to plug it into the original equation, we take 2, we plug it in, 2 minus 2 is 0 in the denominator, which we can't have. So this is not a solution, and we just write no solution.